All right, let's continue with the sine and cosine functions. This time we want to graph a given function, and we're going to always graph it in reference to the original parent function. Let's actually go over the components of the standard form of the transformation. So I wrote all the information here for you. The only thing that I want to reiterate is a couple of things. Couple of things is that one is if the leading coefficient is negative, remember with the polynomial function is a reflection over the x-axis, and the next one, if b is negative, is a reflection over the y-axis. And the other part is that the equation of the midline that you need, it will be the plus or minus t, whatever that would be. Okay, and now we're going to go ahead and look at this equation, this function, and we want to graph that. Then we're going to come up with all the components. So first, let's come up with all the components of this graph. So we know that 2 is the amplitude, and it's absolute value. That means it's always positive. If it's negative, that's not negative to amplitude. Amplitude is always positive, so you use absolute value setup for that, just the way I've done it right here, and you can see that. The next one is the period of the function. The period of the function is that coefficient that is in front in here, right? That's the b value right there. The b value in there is 1. Okay, so that's the b value there. So that's 2 pi over 1. That would be giving you 2 pi. That's the period of the function. Great. The next thing is we're going to look at is the negative pi over 6 within the bracket. That means the positive shift to the right is a horizontal shift, and here it is a pi over 6 to the right. And then the last piece is the -1, and that's your vertical transformation or translation, which is in this case dropping down the graph by 1. What is the equation of midline? That would be y equals to -1. That's the equation of midline right there. All right, so now when we go in there, you need to, first thing that you have to do, you have to know the graph of y. This graph, the parent function, it is super important to know this graph inside out. You have to memorize it. You have to know the details of it, everything about it, because everything is referenced to this if you want to graph this accurately and properly. All right, so let's go ahead and graph this. Okay, so here is the graph of the original y equal to sine x, and I wrote the equation in here. And also notice that the partition that I use, the interval for x, the degrees that I use is pi over 6, because I've given pi over 6 in here. Whatever this would be, that would be the interval that I create, and that's what you should do as well. Okay, and the way you do it, by the way, in Desmos, you have to go ahead and change the setting with Desmos, and you go up here with the wrench graph settings, you click on that, and then what happens is that you will see all the stuff that you can do. And I changed my settings, for pi over, just changes it into decimal, but you can actually manually change that. And then the vertical as well, you can change it as well. All right, so that's what I did. The next thing is that when you have the original graph set up, so that's the original graph, very nice. The very first thing we have to do, we have to follow the order of transformation. So this 2 comes first. That is our amplitude. That means there's a vertical stretch is happening. That means every single y coordinate of the original function in here, it's going to get stretched by a factor of 2. So if it was 0, 0 in here, becomes now 0, 0, 0 times 2 for the value of y. So this 0 times 2, that's 0. But if you come up here, notice that it's pi over 2 and 1. That's another coordinate there. That means the y value is 1. That means the new y value will be 2 times 1, which would be 2. So if I click on this and start that, you notice that all of these coordinates, so that point has been moved up or stretched up. The zeros stays 0, but this coordinate -1 becomes -2 for y, and so forth and so on. And every single point on the original graph will stretch by a factor of 2. That's the first order of the business you got to deal with. Next one is that you have to look at the horizontal expansion and compression. In this case, as we wrote it, b is 1, the period is 2 pi. There is no horizontal or horizontal expansion or compression. That's just 1, you let it be. The next piece is the pi over 6, the negative pi over 6. Now we said that when you have pi over 6 inside and it's negative, that means the graph is going to move to the right. So this 0, 0, this coordinate is going to move to the right here. That becomes pi over 6. Okay? So, and then every single point. So now the dark point, the black point now is going to move because we already shifted the graph. We have stretched it. Okay? So that would be the graph that we're going to have. So now everything is going to move by pi over 6. This coordinate here was pi over 2, is going to move to pi over 6 to that coordinate. Remember, each of these intervals are pi over 6 intervals. So pi over 6, pi over 2 plus pi over 6 is 2 pi over 3. So it's going to be there. Okay? And pi plus pi over 6, pi plus pi over 6 will end up being 7 pi over 6. 3 pi over 2, which is right here, 3 pi over 2 plus pi over 6 will be giving us 5 pi over 3. So, and of course, you know, you go ahead with every other point. Now, if I click on that, notice what is happening. Every point has been shifted. Okay, so that's how you have to deal with this systematically. You're not going to graph it all at once. You're going to do it one step of a transformation at a time. Okay, so now that we have that, the last thing you have to deal with is the -1. Okay, so here is the -1. That means all these coordinates that we have, these are purple coordinates, it's going to drop down by 1 unit. Drop down by 1 unit. Drop down by 1 unit. And when we do this, comparing to the purple points, this was 0, now it's -1. 2 becomes 1 because everything drops down by 1. 0 is -1. These are all coordinates for y. -2 with the purple becomes -3. We are doing order of transformation, and -1 becomes, after being 0, they drop down by 1. Notice that all of these x values are the same. We haven't changed any of these. I just put them in a compact form right here in simplified form. Okay, so if when I click on that, notice what has happened. The green points are your final points that has to go through the graph. And if I go ahead and click on the original graph, it should go through the green point, and it does. Okay, so the red graph is your transformed graph of this function, and this is how you have to do it, a step at a time. Another thing, equation of midline. Notice that this is -1 right here. Y equals to -1. Very good. What is the amplitude? Amplitude is 2. So as that right there, you can see that. You can double check that based on the graph that you got. Now notice a couple of things. The x-intercept of the original function, the sine x, is changed, obviously, because the graph is going to cross the x-axis at different points. In this case, it's going to go through pi over 3, pi, okay, and 7 pi over 3. Great, okay. And of course, by the way, this is periodical, so the graph goes left and right forever. Is a wave. Okay, so you can, if I can zoom out, notice that it can go on forever. Okay, so that is how you have to go through each of these functions.